Hello everyone, welcome back to Advent of Code 2020. We're going to be doing day 11 today, although as you can see, we're very nearly ready for day 12. I didn't have time to do a recording yesterday or to work on the problem at all, so I put it off till this evening. So this is one nice advantage, I guess, of being a day behind in uploads, is not only does it mean people can watch my stuff without worrying about spoilers for their own thing. It means that I can take a day off when it comes up unexpectedly. So anyway, I actually already read this problem and had some thoughts about how to solve it, which we'll talk about once we're finished. Once I'm finished reading you the problem. Day 11, seating system. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early nobody else has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout. Seat layout fits neatly on a grid. Each position is either floor, an empty seat, or an occupied seat. For example, the initial seat layout might look like this. Sure. Now, you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat in one of the 8, nearby positions. The following rules are applied to every seat simultaneously. If a seat is empty and there are no occupied seats adjacent, then it becomes occupied. If it's occupied and 4 or more seats adjacent to it are also occupied, it becomes empty. Otherwise, the seat state does not change. So this is very reminiscent of Game of Life, right? The cellular automaton kind of thing, with a different set of rules where, in addition to like alive and dead, we have these states, these cells that can never become alive. Yeah, and of course, first everything gets filled up because all of them have 0 neighbors next to them, and then blah blah, it goes for a while, and eventually it settles down. Right. Eventually it settles. In general, Game of Life is not guaranteed to settle. I suppose that since this problem is a generalization of Game of Life, I think it's probably also not guaranteed to settle, but maybe it is. Because even if you remove the floor cells, it does have a slightly different set of rules for when it becomes occupied. So maybe even if you made everything open seats, I think it's probably not guaranteed to terminate. Anyway, but of course our puzzle input will be one that terminates. And before we start implementing a solution, as I said, I read the puzzle and I put some thought into like how you would solve this. There's like a very obvious thing of let's just model like a 2-dimensional grid of vectors or arrays or even lists, and store in each position the current state of the cell. Or indeed, you could use like a map keyed by pair of int, which I find is easier to work with in Haskell than an array. Although I don't know. Maps always perform fine, and they're so much easier to understand than arrays. I have like done some array stuff. I think in like last year's Advent of Code, I could go looking on GitHub for my usages of arrays and see if it ever makes any sense to me, but it probably won't. But one thing I did want to like at least talk briefly about is another approach to cellular automata, which I read about like, I don't know. I think I read about it like 8 years ago or something. Right? It must have been. Just like trying to think about what job I had when that happened. Which is not an approach I'm going to be using today, but is a kind of cool one. And I wanted to look on GitHub for my previous Advent of Code solutions and see if I had done something similar before. The idea is this notion of a zipper, which is... Oh, that's right. GitHub has dark mode now. I could change this, right? I'm like kind of afraid to do that on camera. Who knows what might show up if I go edit my settings? Let me just another... Settings in another window here. Appearance is a new setting. If I say default to system, it does indeed turn dark because my system sends dark mode preferences. Cool. Okay, and so if I refresh, yeah, oh, that's so much more relaxing. All right. So a zipper is actually a more general concept than this. You can take a zipper of like, there are many kinds of data structures, and for many, although I believe not all data structures, you can compute a zipper for that data structure. And a zipper is kind of like that data structure, but with a focal point in it somewhere where you're paying attention to. And so what I've written here in this 2017 day 17 is the kind of classic zipper for lists. You are, although there's multiple different like formulations of the concept of zipper, and the ones that I'm familiar with these days are called I don't even remember. They have an official name, which is like, I know there's a Hewitt zipper. I don't know if mine is a Hewitt zipper. But I've heard them called one-hole zippers because the focal point is like a place where the data is missing. So you would have like, in this case, our zipper is the element we're looking at, and all the stuff to the left of it, typically written in reverse because lists are singly linked, and so stuff at the front is much easier to access, so you want the neighborhood backwards. And then the stuff to the right of it. An alternate construction for zippers, I think, would be just a pair of lists where the focal point is kind of the point that doesn't have data. Anyway, and these zippers, you can do a lot of cool stuff with zippers. Like, I remember reading an article about how you can look at one-hole zippers as derivatives in the calculus sense of data structures, and how you can use that to like model regular expressions, and like, I don't know, it's super cool. Some theory stuff if you're interested in reading, but apparently I'm using a slightly different zipper here today where you actually look at the focus, which seems pretty useful in general. And the idea is you can easily even though in Haskell you have only singly linked lists, it's kind of hard to move left and right in a list, right? Because, okay, moving right is easy, but how do you move left? You have to like keep track of your current index, and then like keep track of the start of the list and step forward that many times -1 to get left, which sucks. And so this formulation of a list lets you have a focus element in a list, and it's kind of like the functional equivalent of a doubly linked list in a way, right? Because you can get to the left or right cheaply. And this is quite useful for modeling cellular automata. And it's also like, I believe every zipper is a comonad. I don't really understand comonads at all, but they're like, what if you took monad and reversed the arrows of everything? This is a thing category theorists do all the time. Is like, if you look at some category and you reverse the direction of the arrows, you get an interesting category that's different. And so like you can do this for Haskell function types, I guess. Anyway, if you reverse the arrows in monad, you get comonad, and it turns out that those are interesting too, although I don't understand them nearly as well as I understand monads. And so this is a one-dimensional list. It's actually like reasonably straightforward, I think, we have a 2D grid, how would we use a zipper? Like, you could have a kind of like okay, you could imagine a two-dimensional grid where you have somehow a focal point in the middle. But how do you represent that? Well, you could represent it as a zipper of zippers of lists. Huh? Where like the main zipper, if you move left in it, you're kind of moving conceptually up. If you move right, you're moving conceptually down. And if you look at the current focus, you're just looking at the current row. And then once you look at the focus, you now can move left and right, and you're moving left and right in the grid. So you can use this as a way to represent like a single cell's value and the neighborhood of points around it, which is exactly what you need to implement cellular automaton rules, even things that maybe there's a rule, it's like, oh, you got to look 2 steps to the left sometimes. Well, this gives that to you, right? You can look as far in either direction as you want to, but the data that's closest to hand is the adjacent stuff. However, like, I don't really understand the theory well enough to get much advantage out of doing things this way. It turns out you can do cool stuff like, the comodatic equivalent of join, which is called cojoin, apparently is actually exactly running one generation worth of stuff. I don't know. It's bizarre. You can read articles about it. It's pretty cool. It just looks like cellular automaton, zipper, comonad. You'll find out interesting stuff. But today we're not going to do that. Because, as I said, I don't understand it well enough. We're just going to use a map from pair of int to a state and a simple function that iterates over all the key value pairs in the map and updates their state accordingly. So let's do that. Where am I? Well, every time I hit new, it's like, oh, tmux's new. No, that's not what I want. Stack new day 10, 11, AOC. By the way, can I just complain about stack new briefly? I think I did this last year, but these arguments are in like the wrong order. It is a bad order. It's kind of nice that like stack new and then the repository name is like stays the same whether you're using a fancy template or not. But this order is wrong for two reasons. One, it would be really nice if I could say cd2 and then say please enter the last. You can hit like meta dot here, or I believe dollar dot. I don't remember. There's some. It's been a long time since I've used it. Ever since I learned metadot exists. But metadot is like the last argument of the previously run command, and so it's really nice to be able to say cd or make dir this directory and then cd2 that directory, right? And this is kind of functionally similar. It makes a new directory, and it would be nice if you could just use metadot to go to it. Git clone does that, right? You say git clone, https some repo, and then you say into the destination, and then you can metadot into that cd metadot gets you that destination. It's really nice. The other reason it's wrong is it kind of makes sense if you wanted to say I'm making a new web project. So you could say stack new web my server, right? Clojure's project creating thing, line engine gets this right? You can say line new web foo or whatever. It makes a project named foo based on the web template. Anyway, not the biggest deal in the world, but just a minor nuisance I have to grate against every time I use stack. Cool. I might as well kill that buffer, right? And that one, and that one. All right. Hello. Wait. Why is that one still? No, that's fine. We go back to day 11, and we can look at source, and we can also look at our input, which is 95 by 91. Wait. Yeah. It's a little confusing because it starts with 0 here and 1 in the rows, which I never noticed. Like going from row 1 to row 91 means there are 91 rows. And going from column 0 to column 95 is sort of fine because it's actually taken me. It skipped 95 elements, right? 1. Because go to end of line takes you past the end of line. This number here happens to actually be the number of rows and number of columns. Okay, whatever. So we're not going to need applicative do today. We might need lambda case. Who knows? But we need some imports for sure. And so one thing you could do is you could use an int map of int maps to represent like the to represent your grid instead of using a map from pair of int. I don't really have any idea which of those performs better, but it seems conceptually cleaner to use a pair of ints, so I'll do that. Qualfeed, how about qualified? Okay, what else do I need today? That's the only thing that immediately springs to mind. I'm sure there will be more. Well, we'll need a few obvious things. Most notably, we need a data for our, what do they call these? Do they call them seats? Kind of. It's a position. Sure. So our position is either a floor or seat or occupied. And that's sort of all we need. I mean, we could say empty or occupied. I guess, I don't know. Calling it a seat feels better to me because empty kind of suggests floor in my brain. So we'll do it this way. And I think, I wonder, like what might part 2 be? It might be changing the transition function, right? For like, for how to determine whether a thing is occupied or not in the next generation. But we can say that our type, I don't know, layout is a map from int and int to position. And our input, I think, should just be a layout. And we can read this somewhat simply. Let's see. We just need to like zip stuff a bunch. Equals zip m dot from list of do, and I'm just gonna, as always, I'll write it as a do notation instead of as a do comprehension instead of a list comprehension. So what we want is 0. No, stop. What are you doing? Y and row zip 0 with lines input, and then x cell will be zip 0 with row, I guess, and then we will return pure of yx and parse cell, where parse of this equals floor, parse of L equals seat, parse of hash equals occupied. And these pattern matches are incomplete, so it will complain, but that's all right. I mean, I could handle this better, but I don't really want to. So let me then just make sure that I have all this right, and we'll derive show here, and part 1 will just be, well, just comment out the type signature so I don't have to write out map. It's just layout actually, I guess, but okay. So if we were to say stack run, hopefully we would get a map, and it would look completely illegible, but I would be happy that we had parsed it. There you go. Looks good, right? We have a bunch of seats and a bunch of floors and no occupieds. I guess we didn't need that. Occupy, yeah, that's a good point. Throw that away. Okay, cool. So I think it would be prudent. Yes, that's the word I'm looking for. It would be prudent to write our stepping function sort of polymorphically, where it steps a grid with, but does not like hard code a transition function, right? I don't know. That's actually a little bit tricky because I don't know exactly how parametric I need to be. Did I say polymorphic earlier? I meant parametric. Hope I got that right. Because the obvious change to the transition rule would be like, oh, okay, I didn't mean 4 adjacent things makes it empty. I meant 3 makes it empty, right? But there could be other changes, like, oh, actually, people just really hate it when someone sits to the top left of them. Or when someone is 2 seats to their left. So I kind of think, I don't know. I guess the thing to do would be, yeah, to make that. Oh god, what if part 2 is like, actually, it's okay for things to be infinite? Then we would have to make some changes. I don't know. But I guess we can write something that just says, okay, well, given a, I don't know, that almost like doesn't do anything. I said, given like an int-int pair, how should I update that int-int pair? But that's just like map dot. There's like that function must exist in data map, right? Haskell data map is like map with keys or something crazy. Data map strict. Traversal map with key. Yeah. I mean, which is actually pretty great that we have map with key, right? I think we want to use that. Well, traverse maybe with key. How cool is that? So you can say I don't need it. Anyway, we don't need all these other things, I don't think. All right. Right, back to the program. So I guess what we want to say is like next state of is a function from layout to in. I really want to type for this int type chord equals int. There we go. And then we want a position, right? Yeah. Right? Actually, it's going to be, if we're going to use data maps map with key, we should probably take the current state as a direct argument instead of just looking it up in the coordinate, because it's going to give it to us anyway. Map with key, it wants you to take the key first and then the position. Okay, so next state of G, L, I don't know, you'd never name a variable L because it looks like 1. G is fine, it's a map. Well, it's not a graph, so let's go. I was saying G for grid, I guess? M is fine. M K V. Well, I mean, we can just pattern match here. Case V of and then If it's floor, it's always floor. Oh, you know what? We're gonna need equality for this also, because we want to be able to say that the map, the layout has stopped changing. Okay. Anyway, and if it's out for any other position, then I'm combining these in a way that seems sort of awkward. I don't know. This is kind of dumb, right? My thinking was there's some shared computation that I want for seat and occupied, right? Which is how many neighbors they have that are occupied. And you could restrict that work to a where clause that is specific to the positions seat and occupied, and not have it be in scope for the floor. But like that creates a problem where you'll have to do an inexhaustive pattern match here. You say case pos of occupied seat, and you're like, well, what about floor? And like you can see that floor is not possible, but like it's kind of gross. And also, you don't really have to do this, because you can just have a where block that is shared among all cases, and as long as no one ever looks at it, it doesn't waste much time. So we'll just say semicolon, writing too much Java, where live neighbors equals 0, and we'll update that for later. We'll implement it. I mean, it's actually easy. Well, it's easy to write it if you don't bother implementing the things it depends on, right? The top-down approach is very simple. It's length of filter equal occupied map m.find no, it's find with default, right? Yeah. m.find with default floor, I guess. For things that are outside of the seating area, we might as well call them might as well say that they're floor if you try to look outside the bounds of okay, something like that. And we'll have to implement neighbors as well, but the idea is neighbors is a function that takes a coordinate and returns to you all the list of nearby coordinates. We've all implemented this many times, I'm sure. So now we can just say if it's a seat, then we want if live neighbors is greater than or equal to 4, then seat. No, hang on. What are the rules? If it's empty, i.e. a seat, and there are no occupied seats, then it becomes occupied. Oh, I always forget. I'm so used to like writing pattern guards for function definitions and not for case matches that I always forget that you have to write an arrow, not an equal sign here. It's easy to remember here for some reason, but remembering it after a pattern guard, I always forget. And if it's occupied, sorry, if it's equal 0, then it becomes an empty seat. Otherwise, it's occupied. Is that about right? Yeah, that seems fine. So we have to implement neighbors. But if we say neighbors is a function from coord to list of coord, neighbors equals neighbors equals, I guess, map add of do tail of do dy from 0, 1 dx from 0, 1. Now you could do some, like, I don't know, dy dx. You could do this a little bit fancier. X1, Y1, X2, Y2 equals X1 plus X2, Y1 plus Y2. Map at what this is clearly typed wrong, not just because of the red line, but because it makes no sense. Why was I thinking this is right? All right, whatever. We'll just say map. Yeah, this is what I actually meant. Not X, C. The keys are right next to each other. And so if we test this, we can say neighbors of, I don't know, 3, 3. What? Oh, I forgot it's -1. Oh, okay. Right. 0, okay. 0, 1, -1. 0, 1, -1. The reason it's important that the 0 come first is that that's how I'm removing the 0, 0 case. I'm generating a list of 9 neighbors, and then I'm throwing away the middle one by calling tail. And so you can't just say, oh, give me the integers from -1 to 1. You could remove the 5th element of that if you did, but that kind of sucks. So this is also, like, highly questionable. Somewhat tacky, perhaps. But as you can see, it generates all combinations of, like, 4s, 3s, and 2s that make sense. And so we have our next state function. And now we can use that to say, let's say tick, not text. Why would I write text? The letters are sort of close to each other, I guess. Tick is a function from layout to layout. And tick is very simple. Tick is just m.map with keys, map with key of actually, I kind of need the layout available, don't I? Map with key of next state. Actually, it's uncurry of next state m. I have to apply this to m. It's worse now. What's wrong here? Next state, when applied to a map, yields a function from coordinate to position to position. Map with key, and if we uncurry that, we get a function from pair of key or coordinate Oh god, position is such a horrible name. Why did I call this position? Jeepers creepers. I don't know what else to call it though. I'll just call it usage for now. So when we uncurry this, I wish you could tell me this type. I guess it doesn't type check anyway. So, but when we uncurry it, we get a function from pair of coordinate and usage to usage, and map with key wants a function from. Wait, you're not supposed to curry it? Yeah, of course you're not supposed to uncurry it. What am I thinking? There you go. So this should update the whole thing for me, right? I almost can't resist the urge to be fancy here. I'm not gonna actually leave it committed, but we can write this point free as mmap with key next state. Oh, this is horrible, actually. Wait a minute. Is it just join that from import control monad join? It actually is. Like, I don't propose anyone write code in this style, but I've talked before about how the monad for functions is function, taking a fixed input type, but returning a polymorphic output type. And so for functions, join f is lambda x fxx. And so this is kind of like the fancy way to handle arguments needed multiple times without having to give them a name necessarily. And there are occasionally cases where this is a cleaner way to write things, but I mean, like, I don't know, almost never, right? But it can be shorter. In particular, if you're not giving the function a name, you can just, like, if I didn't want to name tick, maybe I would just use this in place. In the same way I've used like zip combined with tail in some previous problems. But I don't know, just a cool thing that I was like, oh, I see this duplication and I had to give this thing a name. How could I have avoided it? And I heard that it's actually like reasonably simple, but much harder to read, so we won't write it that way today. Let's simplify this a bit, or not simplify, but I don't know what it's choosing as my tab stops here. Very interesting. How about there? That looks good. Okay, and so part one is now getting pretty simple, right? Part one of, well, speaking of which, I guess we're going to use zip combined with tail, right? Part one of, I don't know, we'll do it with variables for now, with not point free, right? And if it turns out it's fancier point free and actually legible, maybe I'll refactor it. But my thinking is we first want to let states equals iterate pick m. Final state equals, let's just say pairs equals zip tail over states. So now we get a list of pairs of all adjacent pairs of time. What am I saying? Snapshots at points in time of the states. First, do equals first of drop while uncurry of equality over pairs in what is it I'm meant to know? How many seats are occupied? Length filter equal occupied over first dupe. Why are we mad about? Oh, yeah, sure. Oh, filter actually takes a list. It's not specialized to. Yeah, because it has to take. All right, that's fine. I was just thinking that since maps are foldable, this would work, but filter doesn't take a foldable. It actually takes a list because it has to return a list. Okay. So we'll just say m dot vowels. No, vowels doesn't exist. What's it called? Conversion to lists. Elms. We're looking for elms. There you go. Seems good. Let's run it. Why is there an empty thing at the end of that, by the way? Oh, that's the part 2 output, I see. 0. There's 0 occupied. Well, that doesn't seem very good. That's probably not the right answer. I know why that's wrong. Because I said drop while they are equal. So it's just looking at the initial state. What I should have done was said drop while they are different. And it'll keep going until you reach a state where the transition function leaves things the same. 2204. That's a quite plausible number, I think. That's the right answer. Cool. Let's get that committed. Sorry, here you go. Not very exciting watching me write commit messages, I'm sure, but especially if you know what they're going to say. Day 11, part 1. All right, back to the puzzle. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats; they care about the first seat they can reach. They can see in each of those 8 directions. Okay. Yeah. So. Oh man, doing it with zippers would have been so great. Maybe. The first seat, so not floor. They're looking for seats or occupied. The leftmost empty seat would see only 1 seat, and that's this empty one. Okay. Got it. And people expect 5 instead of 4. Sure. So this is why I thought it might be useful to parameterize by a transition function. But the transition function is basically just map with key. So I think that what we want to do, we can't just parameterize by a function that takes a coordinate and returns a coordinate. It needs an entire graph to determine which states to look at even, right? So I think we need to add just a couple more arguments to next state to address how we expect or how we want to be able to adjust things. So next state will take first a function from Yeah, function from coord and usage, no. Layout and coordinate, let's say, to I could say list of coordinate, which is like, oh, here's where you're like supposed to look for neighbors. But since I have to look for neighbors in that position anyway, it's like gonna be kind of silly. So I could have it return number of occupied seats, but in that case, like, what is it even doing? What is next state doing if we move the number of adjacent seats into this thing? Okay. Well, one thing that seems clear is that this list kind of needs to be defined at the top level, and this is something I often do anyway. Deltas is a list of coord. Deltas equals this. Oh, and I kind of want add as well. Sure. Add is a function from coord, add equals this. And something that I in previous years have like done because I think it's really cool is use the monoid instance for tuples to handle this pairwise addition, right? It's kind of stupid to have to write all this out, right? And it turns out that tuples have a monoid instance that's very useful. You can say x, y, a, b, say, is equal to, this is in the standard library, this isn't something you would have to define, y, b. And so if you have a tuple of two things which are themselves monoids, you can just use the monoid composition operator here to compose your two monoids pointwise. And it turns out that numbers are monoids either under addition with 0 as the neutral element or multiplication with 1 as the neutral element. And so I thought it was rather clever to have my coordinates not be a pair of ints, but a pair of sum of int, saying I want to use the sum monoid. And then you can just add together two such things with mappend instead of implementing your own little function. But I don't know. People have told me it's kind of tacky, and I can see their point. Why use that mechanism, like the polymorphism, when you don't need it if the function is so simple to implement yourself? Which, okay, fine, I guess. But anyway, all of this stuff is going to be useful in our part 2 thing, where we're going to basically say to scan for a long time in a single direction, and we're going to need to be adding. We're going to say, oh, for each of the 8 directions, try scanning for a while in that direction. We'll need add to handle scan. We'll use, I assume, scan L of add to give us all the points forever. And by the way, we will need to change here. Well, I was saying fine with default of floor, but since my idea is to keep scanning until you run into either a seat or an occupied seat, it would be kind of nicer if this were to find with default and until you get if you fall off the edge of the map, it would be better to call that an empty seat because you know there won't be any occupied seats behind it. So maybe I can extract this part out. Without while still trying to leave some of this. Like, this is looking mostly equal, or not equal, specific to part 1. Whereas this I'm going to need in part 2, except that I'll need to change the 4 to 5. So what I think I will do is extract a function for this. Transition the function from int to function from position and int. Well, let's flip these, I guess. Transition pickiness neighbors the equals and so now we can say transition and we want our transition function here somehow. Ugh. This is, oh, it's not a position, it's a usage, thank you. Oh, and not an int, but usage. So we can say transition 4b. Yes, sure, I could either reduce that. But I'm not sure how much of this is actually very useful. Like, I'm really kind of struggling with next state and tick and part 1, because so much of what these are doing, like, I don't know, a big chunk of it is generic to both parts, but also a big chunk of it is specific, and figuring out how to extract the duplication in a meaningful way is interesting. I could just rewrite, like, I could write a new next state function and a new tick function, you know, tick 1 and tick 2, and that would certainly be the fastest way to finish solving the problem, but it doesn't really, like, reflect what I try to do with Advent of Code, which is to have a good domain model and, like, have a program that represents an understanding of the problem. My daisy chaining solution the other day of just, like, composing 15 functions notwithstanding, I do usually like to write a good domain model. So what I'd like is a transition function, or a next state function, that is, as I said before, parametric, that takes in a way to decide who your 8 neighbors are. But it's really tricky, I think. I don't know, maybe it's not. Maybe what I need to take in is a function from layout and coordinate to list of usage. And each of the ticks have to, like, handle their own looking stuff up in the map, but it's not that hard to do so. So we want to take in a function from, what did I say? Layout, coord, usage. And I think here we just want ends. No. Ah. Ends of M. No. What's wrong here? Oh, not map. Sure. Okay. And now we can extract what we had written here as a part one transition, as a part one neighbors. Yeah, it's a little weird because we have something called neighbors already. But I guess good news, we don't need neighbors anymore, right? So that can just be our part one neighbors. We'll just adjust it here to take the type that I actually want, which is a layout. Hang on. Those are just ordinary arguments. MC. So in this case, we can just completely ignore the M. We don't need to know the layout. Oh yeah, I do. So we're going to do something like this. This is not right. I see that. Why is it not right though? Maybe the type error will tell me. Taking a layout, I'm going to say flip flying with default, and here I'll change it, I guess, to seat. Add C. So for each delta, we add it to our current coordinate, which seems good. Do I just like apply rather than compose? Is that the problem? Well, now I don't. Now that I'm not composing anything, I can just write this the normal way, right? M find with default takes the seat function, and then it takes a key. Oh, what? No, because I am composing things still. Ugh. This should be composition, shouldn't it? M find with default seat. That applies the default. Then I flip it so that it's expecting the map. Then I apply the map. And now it's a function expecting a key, and I compose adding with C. Am I crazy? What is wrong here? Oh, I got rid of one of these parentheses. All right. And now it's just telling me. Oh, it's telling me I wrote the type wrong. The function was implemented correctly. I just gave it the wrong type. Okay, cool. All right. So now, does part one still succeed? No, because we haven't updated tick. Tick takes a... we should probably define a type for this. Type ticker equals this. nope, hang on. I guess I never actually put the word ticker into my base buffer? Okay. I wrote it twice. There you go. I guess we'll call this T now that I've got a name for it. Ends the neighbors thing seems a little dumb. And we can squeeze this all onto one line reasonably comfortably now, I think. There you go. Tick. We need to iterate tick of neighbors. Right? Okay. So now that we've done this, first of all, let's just check that it still is correct. We're looking for 2204. Uh-oh. It's not completing. Alright, that's sort of a problem. Alright, yeah. Not great, not great. Oh, right. Why am I still flipping this? Hang on. Just tell me what I should have written. Oh, it's just got redundant brackets. Okay. Remove the one after M and this one, I guess. Well, this is a little bit problematic. Oh, transition is pinned to 3 still, though, huh? Wait, why 3? Should have been 4? So I need to actually lift the pickiness up into the transition function, I think. 2204. Okay, that's still correct. Now I need to figure out how to extract this. Which I think is simple enough. Next state just needs another parameter. We'll call it pickiness. And tick also needs such a parameter. I don't know, I feel like a pickiness and a ticker is like a useful pair, right? So maybe what I should be doing is not putting these into like just type aliases, which are not that meaningful. Like give them a real like data. I guess I still want the type alias at least for ticker, but maybe I don't need one for the pickiness. What do you call it? You'd call it a problem or a part or whatever, but there's a better name for this. Parameters, I guess. Okay, and so each of these functions actually take, hang on, neighbors, I didn't update this to be a ticker. It does not take a pickiness. Rather, it takes a... Oh. It does, though. Well, this can just take an int, because it doesn't need the other stuff. That's fine. But next state needs a parameters, not just a pickiness and a ticker. And tick also needs parameters. I wonder, this is the kind of thing that it might be better to like explicitly use the reader monad for like Like application preferences is kind of what this is, and that's like what Reader is kind of good at, is stuff that you mostly don't care about most of the time, but you need to like plumb through to the bottom sometimes. It can be, we're not going to, but I think it might be nicer to have done so. Anyway. Actually, I don't need the destructor here. I can just call it P. There you go. Why did this not compile? Multiple definitions of tick? Ah, I see. And so now instead of just neighbors, we're going to say parameters of a pickiness of 4 and neighbors as the way to step. Okay, we still get 2204. Good, 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 good. Our refactoring has not impacted correctness. Okay, so now I think what we'll do actually is git commit this. Day 11 prefactor for part 2. And now the only thing left to write, oh, actually, we'll write solve as a function from parameters, that's how you spell it, to input to int. Solve p equals, let's put the p here, and then part 1 is just solve of that. Where did my m come from? Oh, of course, it's a parameter to this function. This still compiles, and I suspect still runs. And hopefully gets the right answer. Yes, okay. So let's git commit amend no edit. No edit, thank you. All right. So now it's very clear. We just have to implement a new parameters function for part 2. And everything else will be fine. And this is kind of the factoring out that I was looking for. Why are you mad about next state? This one too? No, the definition, who cares? I guess I could call it P, whatever. You got me, fine. I'll use worse variable names. You happy, HLint? And I guess I'll do this one too. Okay. So now we just need a new function, distant neighbors is a ticker. Distant neighbors of M and C equals let's write a do here. That seems way better. So I'll be able to give names to my intermediate variables and think things through a little more clearly. Direction from deltas. Let's choose a direction to walk in. And then we want positions. Well, we're calling these chords, right? So chord is tail, iterate, add C of direction. And then we will say let usage equal M dot find with default of, it wants default and then the key, yeah, and then the map. Okay, seat chord m. Guard that usage is not floor. Hang on, this is not right. This should not be a nested do notation. This is incorrect. Yeah, I should be saying this should be an a let actually. Oh, now is where I want the stupid. I need this to be a damn function, honestly. Let's see. Lookups. Well, we'll just say lookup, and we'll give it a we'll call it with map every time, but it still seems better. Oh, don't call it lookup. That's in the standard library. Seat at is a function from layout and chord usage. Seat at m. Oh, it's a little tricky though because no, it's fine. I just want this basically, right? And in fact, are you kidding me? Really? This is gone as well? I'm like doing almost nothing? Okay. Usage is equal map seat at, which takes the map first, I assume? Yeah, map m over chords. Actually, maybe the point is that I wanted this to be a separate do. Maybe that's what I was thinking. I want to iterate over each of the, yeah. Well, no, because I have to do a drop while, not a guard anyway. That's dumb. I don't want a guard. Target equals drop while equal floor usages. In target? Why is my tab complete? Oh, there's no in. Right, we just need pure. Head of target. Okay. What is wrong here? Okay, first of all, this is wrong. I broke this, which is a little annoying. See that M? Why are iterate, add, and C all wrong? So I have a single direction, and I want to iterate. Oh. Oh. Because I'm not actually using deltas is just the delta directions. iterate. What I want is add direction starting at C. There we go. That seems a little better, right? Yes, okay, so direction is our delta. And we start at C and add things from that direction. Okay. Now, this entire thing is very clearly just a map of like some relatively complicated function, because we just have a single bind and then we end with pure, and that's obviously just map. But I find it a lot easier to think about written in this way, and I don't think it would be an improvement to make it shorter. So if I then say here that part 2 is a function from input to int, and part 2 is solve parameters 5 of I already forgot what it's called, distant neighbors. And I think I would in principle be done. I mean, it might be wrong, but this is what I wanted to implement. It's a number, and it's close to the other one. Great. Let's see if it's right. Where's my window? Here it is. That's the right answer. All right, so we got them both. The first try is maybe not totally accurate. It was more like the first try that I thought was worth submitting, because we did, after all, get 0 the first time we ran the program. Day 11, part 2. And, like, I don't know. I think it turned out pretty nice, so all things considered, right? Part 1, I don't know. The stuff that we ended up extracting is not, I think, the best way you could factor this, but it does, like, it's not bad. I wish that this, like, parameter thing could be plumbed through a little bit more silently. Inobtrusively, perhaps. Unobtrusive? I always forget if it's in or un. Unobtrusive, right? And this is kind of like wacky, but we got some useful types that like describe things we were doing regularly. Oh, I didn't want join. I don't need lambda case either. All right. Let's just fix that up so we wrote things correctly the first time. Actually, I guess I do want those both in the first commit here. And if we were really, really like excited about it, we could remember a couple things here. I ended up I said this is part of part 2, but like it actually changed part 1 a bit, right? The neighbors thing. I kind of forgot to factor out this seat at function. I think that like maybe the like cleanest thing to do would be to take that diff and move it back to the prefactoring commit. But I don't think there's really any compelling reason to do so. This is fine. What we have so far. Okay, anyway, I hope you guys enjoyed today's item to code. Thanks for watching, and I'll see you next time.